Okay, let's go ahead and classify these different number sets. We're going to start by the most restrictive number set, and then we're going to go to the most open number set available. So first off, the first numbers, what are the first numbers that you ever learned how to do? How did you learn how to do numbers? What was the first thing you wound up doing? Yeah. You counted, right? You guys remember counting? What number did you start out with counting? Did anybody start counting 0, 1, 2, 3? Everybody started counting with 0 for the most part. Most people started counting with 0. How's that? So the first number set we're actually going to use is called the natural numbers, because that's naturally what you start learning with. Does that make sense? The natural numbers, we're going to define those as the counting numbers.
Can you write this down?
Yes, please. Counting numbers. And then those examples of those would be just start counting, guys. Somebody start counting. Except for starting at 0. So 1, 2, 3, 4, and then so on and so forth. How many counting numbers are there? How many counting numbers exist? An infinite amount, right? They go on forever and ever and ever. Forever, ever. Forever, ever. I knew somebody would get that joke. How did I guess it was going to be you? Funny. Forever. Okay, natural numbers. So the next set are called the whole numbers. Next set are called the whole numbers. Those whole numbers are defined to be the counting numbers, including our favorite number, 0. So a little bit less restrictive and open-ending are the counting numbers and 0, including 0. So it's pretty much the same thing. It's just, if you're not what strange people start counting at. Strange people start counting at 0. So if you start counting at 0 and then you go out, you are naturally a whole number, which is weird. Anyways, so the next less restrictive classification of numbers are the integers. Integers. Okay, does anybody remember what integers are? Does anybody remember what integers are? Yeah. Am I recording? Okay, so the integers are defined to be the whole numbers. The whole numbers and their opposites. Or the negatives. Okay, so examples of that would be like, forever in one direction, so like -3, -2, -1, 0, 1, and so on and so forth. How many integers are there? An infinite amount, right? In each one of these number sets, they're infinitely large. Infinitely large. So let's now, another less restrictive number set versus the integers. We have, above the integers, we have the rational numbers. Okay, which is any number that can be written as a fraction of integers. Okay, so examples of that would be like 1/3. That's a fraction of integers. Okay, -0.5. Can't we can write that as a fraction, can't we? It's -1/2. So that's also an integer. Okay, so then the next one, the next open set is going to be irrational numbers. Irrational numbers. These are non-terminating, non-repeating decimals. Any number that, when you put it in decimal form, is non-terminating and not repeating. Okay? An example of that, the most famous one is probably the number pi. Right? You guys remember that goes on forever and never stops. Okay, another number that goes on forever and never stops and doesn't repeat is the number e. Okay, you'll learn that when you get into the second year of algebra. Other examples would be square root 2 is another example. Square root 2. All the square roots for pretty much, okay, except for the ones that reduce. And then an overarching that contains all of this are what are called the real numbers. That's every number you've ever heard ever forever in your whole entire life. Okay, unless you've any number you've ever studied for the most part. Okay, some of you guys, the smart aleck in you is like, oh, if there's real numbers, does that mean there's imaginary numbers? Yeah, what's up? There are. Tricky, right? If there's real numbers that exist and then there's imaginary numbers. You'll learn about those later. Okay. What we're going to wind up doing now, I wonder if, oh, it's still recording. That's funny. Now what we're going to wind up doing is we're gonna fill those into this different graphic organizer, okay? We're going to work together to fill it in here as a graphic organizer, a visual to talk about those definitions that we talked about before. And then I'm going to have you turn that around and redo it in a different way to organize it in the pyramid that's below. Okay? So, okay. In this picture, you'll notice that there's a square that's inside of all the other little squares. That's actually representative of the most restrictive number set type that we're talking about. Which out of the ones up above was the most restrictive? Which one was the most restrictive? We said the first one that we did wound up being natural numbers, right? That goes in the very beginning. Natural numbers. Outside of that, one step outside of that is the whole numbers, which, as in the picture, you can see if the whole numbers are on the outside of the natural numbers, that means if you're a natural number, you're also a whole number. Like if you're a natural number 12, you're also a whole number as well. And then if you're a whole number, you're also an integer. If you're an integer, you're a rational number. Okay, and then over kind of on the outside by itself are the irrationals. So they're irrational, so we keep them segregated from everybody else. Irrational, where we put irrational people to keep them on the side of the room in the corner. That's a joke. Okay, now what I want you to do, get with your role partner. Put your desks side by side. Okay, and fill out the pyramid down below, please. Okay, in the what did you guys put in this little corner? Yeah. Irrational. Kind of off by itself. Okay? And then over this big one, yeah. I wanted, with the way that I organize it in my head, I would put rational here. So I think we're going to reverse it from each other, okay? As long as you understand how it flows from one to the next, that's okay. It doesn't really matter as long as you have it for yourself. Okay? A little bit more restricted than rational numbers is going to be integers, and then whole numbers, and then natural. My progression on the way that I drew it was I start down here and go up. Okay? To the most restrictive set. Okay? For instance, if I am in this spot right here, if I'm like the number, if I'm like the number 13, which is up here, I'm also a whole number, which means I'm an integer, which means I'm a rational number. Okay, which then in the whole bank, anything that's in there represents the real numbers. Okay. Okay, so now what we're going to do, go to the next page, we're going to start classifying some things. Okay, now when we look at a number, I want you to classify it in the most restrictive name, okay, that we could put it in, okay, the most specific name that you could possibly choose. We're talking about 9/10. You could go down the list. Is it an irrational number? Is it a rational number? Yes. Okay, let's step one, way more specific to see if it fits in that. Is it an integer? Or, sorry, rational number. Is it an integer? That's the next specific. Is that just, no, that's not an integer. Okay, so since it's not an integer, the most specific that we can say is that it's a rational number. So we're going to write down that that's a rational number. Okay, square root 121. Okay. Be careful when you see these. Reduce them if you can. Square root 121, does that reduce? That reduces to what? Does anybody know? Actually 11. 11 times 11 is 121. Okay, since that's 11, okay, is it a rational number? Yes. It's not irrational because it's it can reduce. Is it an integer? Yes. Is it a whole number? Yes. It's actually, most specifically, it's a natural number. Then square root 56. Does that reduce to anything nice? Is that like 5? Is that like 6? Is that 7? Or is that 8? It's like in between two numbers. What two numbers is it in between? It's like, that's in between, like, square root 56 is going to be in between, and we're going to talk about that in a second. Square root 49, which is 7, and square root 64, which is 8. So it's somewhere between 7 and 8. Okay, this is not a rational number. You can't write that as a fraction. This one's irrational because it doesn't reduce. It's an irrational number. That's the most specific way we can say it. I like to rewrite them. Oh, I pressed the wrong button, surprise. I like to rewrite them using just name the numbers with the A, B, C, D so that I can find a good spot for them easier. Okay, so I'm going to name this one A, this one B, this one C, this one D. We're going to fit it on the number line. We put 0 here. We know we're going to have to go to -1.5. So I'm going to have that's between -1 and -2, right? So if I go to -1, then I go to -2. That's like halfway between those. So I'm going to take a guess. That's like -1.5, right? Or -1.5. I'm going to put it there. And then -1/4. Okay, that's going to be, is that going to be here or there? Which one? You got to kind of decide, right? Because if we split that up into fourths, it's going to be like here. Okay, it's closer to 0 than it is to 1. We need to make sure we do that. So then between 0 and 1, it's going to be closer to 1. So we put that C. And then 7/4. 7/4 is what as a decimal? 7/4. Is that more than 1? Ask yourself, is that more than 1? Is that more than 2? No, it's not quite 2. What would be 2 in fourths? 8/4 would be 2. So it's real close to 2, but not quite. Right? It's actually 1/4 of the way off of being 8/4. It's 7/4, which is 1/4 away from 8/4, which is 2. So it's like there. Huh? All right, let's go down to the next one. So we're in graph inequalities. Do you guys remember what type of circle to use when it's just the less than symbol or the greater than symbol? What kind of circle do you use? You remember? We use an open circle. It looks like that. Okay. Does anybody remember what kind of circle we use if it's the equal to part included? The opposite of that would be a closed circle. Okay. So if we have any of those symbols, that's the way we show it on a number line. If we're going to do x is less than 4, put 0, put 4 on the correct side. And then we're going to turn around, open circle or closed circle at 4. Going to be an open circle absolutely to the right or to the left. Do we shade? That's the question. Now we have to shade to represent all the numbers. X, this literally means x is less than 4, or if we say it instead of x, we say the shading is less than 4. We want the shading to be in the picture less than 4. Is less than to the right or to the left? Shading to be less than 4. To the left. Put put negative 0.5. It's the equal part, so we're closed in circle. And we want b to be greater than or equal to negative 0.5. So we want b to be greater than, okay, negative 0.5, or the shaded to be greater than or equal to negative 0.5. Greater than is to the right. Okay, so we want the shading to be to the right of negative 0.5. Okay. Be careful though when you're doing this. Some of you folks might say that we shade the way the arrow points. Don't say that ever. I'm never going to say that to you guys. The reason why we don't shade the way the arrow points is because we don't always do that. Okay? So for instance, if I give you this, if I give you that, and we go ahead and graph it, if I say let's graph negative 4, have an open circle because it's not the equal part. And in this case, we want negative 4 to be greater than the shaded spot. Okay, we want negative 4 to be to the right of the shaded spot. Negative 4 has to be to the right of the shaded spot, which means we shade to the left. Okay? So don't think to yourself that it's okay to shade the way the arrow points. Make sense? Okay, let's look at the next one. Okay, so we're going to wind up thinking about factors on these when we're talking about doing square roots of things. Right now, if we factor 100 into two equal factors, okay, what times itself is 100? Let's do that. Let's just factor that. What times itself is 100? 10. So if we factor 100 into two common factors into the same factor, it'd be 10 times 10. Okay, we can use that when we're talking about doing square roots in our head without doing them in our calculator. So if we're talking about this, we can do plus or minus square root 25 over 100, which is the same as plus or minus square root 25 over plus or minus square root 144. And if we think about what is the square root of 25, we think about two numbers times itself twice. Square root of 25 says what times itself twice is 25. Let me ask you that. What times itself twice is 25? 5. So square root of 25 is 5. How about with 144? What times what is 144? 12? 12. Yep. So plus or minus square root 25 over 144 is the same as plus or minus 5 over 12. And that actually gives us two answers. We have one answer, 5 over 12, and another answer, negative 5 over 12. By the way, I always like to put the negatives on the numerator. Doesn't matter, it could go on the denominator, it could go out front. I prefer it on the numerator. Okay, what times itself is 64? 8. So the square root of 64 is 8. Square root of 16 is 4. We get 8 over 4. Is that our final answer? No, we want to reduce that, right? 8 over 4 is just 2. Okay, so the square root of 64 over 16 is 2. And that's our answer. Can anybody think of a second way to do that problem? Sorry, did anybody find a different way to do that?
No.
Anybody find a different way to do that? Yeah.
You could divide it by 2.
You could divide what by 2?
64 and 16.
You could do 64 and 16 by 2 right off the beginning. You can actually reduce the fraction right away. So if I divide numerator and denominator by 2, we get square root 32 over 8. Can we keep doing that? We can do it by 2. We could actually divide by 4 now. We can divide by 8, numerator and denominator, right? Do by 8. We do by 8 again, and that would be square root 4 over 1. By the way, 4 over 1 is just 4. Square root 4 is 2. Fantastic. By the way, there's more than one way. Mr. Cheek, my old geometry teacher, he retired a few years ago. He used to say that there's more than one way to skin a cat, but they all leave a mess in your garage. Okay. It's a quote from Mr. Cheek. All right. Which just means that there's more than one correct mathematical way to do a problem. You just have to do it, use correct mathematics to do it. Okay? There's more than one way to get to the answer. It's okay. All right, but how about this? We need to determine, estimate each square root to the nearest whole number. What I want you to do is, I want you to tell me which numbers this is between. Okay? Essentially, that's what you need to do. Which whole numbers is it between, or the closest one that you can find for it. Okay? So what is this when we turn it into a decimal, which whole number is it close to? Yeah. Okay, it's between 5 and 6. Can you tell us how you did that? 25. Yep. Okay, so what he's thinking is that 5 times 5 is 25. So the square root of 25 is 5, right? Square root of 36, he's saying, is 6. And square root 34 is between those two numbers. Square root 25 and square root 36. Does that make sense? So it's closest to which one? Is it closer to 5 or closer to 6? 6. It's going to be closer to 6. So to answer this question, by the way, square root 32 is not equal to 6. It's just closest to 6. That makes sense? Okay. What about square root 97? What two numbers is that between? That's really what it is. Square root what and square root what? Okay, so square root 36 is 6. What equals? Square root what equals 7? What times what is 7? Square root 49 is going to be 7. What times what is 8? 64. What times what is 9? 81. What times what is 10? 100. So it's going to be between 97 is between 81 and 100. So the closest, is it closer to 10 or is it closer to 9? It's going to be closer to 10. Okay? To answer the question that's asked. Okay. You guys do have homework. Do you know where you can find your homework?
On the website.
On the interwebs. Why don't you guys, as my brother Chris would say, on the interwebs. Why don't you guys go to it now? Okay, if you have capabilities to do so in class. If you want to, you can just wait until you get home. That's perfectly fine too. It doesn't matter. It's just a good thing to maybe go to it before we leave class in your head, so you can put it with the rest of your stuff. Cool?